Hi there. My name is Dave Shakochis. I'm the Vice President of Product Strategy for Enterprise at Lumen. And we're really happy to be with you today to talk a little bit about how edge computing is transforming use cases and strategies for some of the real giants of the industry across hardware, software, and service provider domains. So we've got a great panel to discuss the edge from that perspective. And I'd like each of them to just introduce themselves real quickly. Dan, starting with you from the hardware perspective in HTC.
Hi, David. Thanks for having us. My name is Dan O'Brien. I'm the general manager for HTC Vive, and I've been with this company for 15 years, and I started the Vive business. So I'm pretty excited to be here and talk with you guys about what is the future and how do we use all of this great, amazing edge computing and how's it going to affect the future of our technology.
Fantastic, Dan. Great to talk to you again. Rick, maybe talk a little bit about your role at Microsoft.
Hey, David. Thanks for having me. It's great to be here. So I'm Rick Levin. I'm the CTO for the worldwide telecommunications industry at Microsoft. And so what does that mean? I get to work not only with our customers in the telco field, but really a whole slew of partners like Lumen, as well as our product groups, our engineering teams that are building products that are suitable for telcos in some way in order to run their business, to run their networks, and so forth. And so I ensure that our customers are well represented when I talk to these product groups to ensure that we're building products that, again, are meeting their demands, that are carrier grade and so forth.
Yeah, huge role in the software space to make those products and those markets fit. Chip Swisher, my colleague from Lumen, has agreed to join us from the service provider perspective. Chip, maybe introduce yourself and tell everybody a little bit about your role.
Sure, thanks, Dave. So Chip Swisher, I run the Internet of Things practice for Lumen. So we operate as a systems integrator, pulling together pieces from our portfolio and the portfolios of all the people represented here, and bring that together into a single end-to-end solution. So we've got a lot of good experiences and perspective in bringing together compute resources, network resources, hardware, software into an end-to-end solution for our customers.
That's great. So a lot of great perspectives and industry insight from all three of our panelists today, talking about hardware, talking about software, about services, and of course, everybody overlaps in those domains as well. So what we thought we would do, given all that perspective and given the diversity of those industries, we thought we would start off by talking and grounding the conversation a little bit in history and what's led us here, what's led us to the edge. You can kind of look at it historically across these periods of technological achievement, whether it was steam power, enabling certain kinds of mass production industries, or electrical distribution really fueling the modern industrial economy, or the dawn of computing power, sort of the dawn of IT and microprocessing, which has now led us into this fourth industrial revolution, which is really geared all around the acquisition, the analysis, and the action against sources of data, and all the different sources of data that fuel the modern industrial economy. That's this fourth industrial revolution that we're right on the cusp of. I think within those last two industrial revolutions, I think a lot of folks have observed how computing power itself has gone through some evolutionary cycles that kind of oscillate back and forth between centralized models and distributed models, right? Where it's the original dawn of mainframe and kind of the dawn of IT, distributing out to client server models, kind of consolidating back towards the cloud and sort of bringing all the business logic into more centralized postures. But now we're seeing this explosion of all the different sources of data, the different ways to process that data, the different kinds of sensor actuator cycles. They can really add a lot of value to customer experiences, industrial efficiency, all these different kinds of business outcomes from the many different ways to leverage the edge, right? So the industrial cycles occurring across decades, the computing cycles occurring across even smaller periods of years have really led us to this exciting time in the industry. And so we wanted to start off maybe talking with that historical perspective as a baseline. Dan, maybe start with you from a hardware perspective. As you think about this fourth industrial revolution era, right, this fourth wave of computing at the edge, how has processing power and the way that HTC leverages it evolved? Right? There was a time where it was all about general purpose merchant silicon. Now we have GPUs and ARMs and TPUs and all sorts of different types of technologies that are a lot more prominent in the industry. How has HTC evolved their thinking there?
Yeah, no, it's pretty incredible. I mean, we started off as an ODM company, right? We were actually making motherboards and chipsets for other companies and other products and PCs. using, general purpose, merchant silicon. We actually moved very quickly into ASIC chips and GPUs and ARM, and that evolved in smartphone technology. A lot of people actually don't realize, I think, with the dawn of what we see today in the XR, world of building these new types of immersive products, it actually evolved from so much of the chipsets. It evolved so much from the smartphones. What's in modern VR headsets and displays is a smartphone panel that was powered by the need to have higher visual quality and fidelity inside of a smartphone. Now we're seeing where we need even more processing power. We need even more visual quality and performance inside of VR headsets or an XR headset, and an AR type of solution. So we're seeing this actually increase in terms of the demand and the overall performance needs. I think it's pretty incredible. The initial products, required large PCs and GPUs in order to make this stuff all work. Now we're actually moving all of this into a cloud environment, and actually putting all of that up into the cloud for users to be able to go to scale and security and performance. So in the essence of the fourth generation, we now have artificial intelligence, machine learning, that's all going to help optimize that for all of this virtual content and interactions. So, this is going to make
all those processors in all those places, really matching all those processors in all those places. It becomes such a challenge. That's great. So, Rick, from a Microsoft perspective, how are you all looking at this historical perspective? I think some of us are old enough to remember software development used to be around just copying files around, right? Getting the software deployed in the right location. It's come a long way as we've sort of progressed through these computing cycles. How has Microsoft really driven a lot of that history?
Thanks, David. You're absolutely right. The cloud really has changed everything, and the edge is really just an extension of the cloud. And so at Microsoft, we talk quite a bit about this notion of the intelligent cloud and the intelligent edge. And it's really a way to deliver applications across the entire computing canvas to where they're needed, to where it makes sense. And as a developer, you like to think that you can build an app once. You want to use the latest technologies, which right now it's cloud native principles, and you want to be able to deploy it anywhere, whether it's the public cloud, up in the sky, or really an edge location. And so this vision that we have of intelligent cloud, intelligent edge is really largely dependent on our telco partners, because at the end of the day, they provide that connectivity, that connective tissue that's required for this vision to become a reality, right? The cloud needs to connect to the edge. And without telcos like Lumen, really, there is no intelligent edge. I like how you drew parallels between the computing waves, right? Because, as people, we love to compare things, right? It's innate. And yes, you're right. There's a lot of similarities between the mainframe to cloud and between client server to edge. It's reasonable conclusion. But unlike the move from mainframe to client server, for example, where in this case, each mainframe and client server had their own unique development models. They had their own governance. It wasn't just about the hardware. Everything was different. The programming languages were different. Cloud and edge are really essentially the same DevOps model, right? It's the same cloud native capabilities that are available in the edge or in the cloud. Certainly in the edge, you may have a subset of those cloud capabilities because of scale, but the programming model is the same. The DevOps model is the same. Same management portal, same management interfaces and APIs. So the edge really just becomes another cloud region for a developer to deploy their applications to. It becomes a deployment target for their cloud native applications. That's a huge difference between mainframe and client server. Yep. Again, as a developer, I'm really amazed at the advances in tooling, especially in the last few years. AI, for example, has had an incredible influence, not only in the applications that we create as developers, but as the applications that we write and how we develop those applications. So the cloud gives you, of course, limitless compute capabilities. That's really at your fingertips. You need 1,000 VMs for supercompute? No problem. In 2 minutes, you'll have them. You'll need 10,000 VMs or containers? No problem. Again, scale is not an issue. But features like serverless computing, for example, really enable you to take your applications to the next level. In a sense, you'll be able to create and deploy complex applications using microservices, using unimaginable simplicity. Things are much different. And as a developer, AI is really, again, transforming the way you write code. I ran into this little product called GitHub Co-Pilot recently, and it just blew my mind. Co-Pilot is an AI pair programmer. We've all heard the concept of AI pair programming, really where you're working with somebody else to help write better code. In this case, Co-Pilot is your AI pair programmer. You can write code faster with a lot less work. It really draws context from the comments that you write in your code, and it uses OpenAI Codex, which is an AI subsystem that's created by OpenAI that's hosted on Microsoft Azure in the cloud. And it's really fascinating how Copilot evaluates the text in your comment, and it processes it. It actually writes code in the programming language of your choice. And so that's absolutely amazing, taking a comment and doing that. So give it a try. Look, search for GitHub Copilot. It's mind-blowing.
So all these preponderance of tools that are really all about being able to develop a software and get the business logic out where it needs to be, but do it at scale, right? Do it at massive amounts of repeatability. That's certainly what I hear you calling out as computing has evolved, so has those tools. So Chip, as we start thinking about stitching it all together from a solutions and a service provider perspective, how have you seen history evolve in the space? Right, there used to be kind of in some inherent complexity to anything that was a technology or an IT problem. Now the cloud and some of the tools make some things easier, but the opportunities and customer expectations make things more complex. How do you navigate that as a service provider?
Yeah, and so I'll give some of my answer related to kind of my specialty around IoT. And so as we see kind of the evolution of IoT, people say, think of IoT as, it's a new concept. In reality, it's been around for 20 plus years. The concept of being able to take data off of machines and devices and do things with it. I've seen really now the wave of what I call IoT 2.0, where where IoT kind of did that same evolution, where you maybe had in a factory floor a localized production line control machine that was doing processing there locally. And then we saw the advent of moving that out to the cloud, and different stovepipe cloud providers providing centralized end-to-end solutions in that space. Now we're really seeing the need for integration, and what I call IoT 2.0 now, where we're starting to see cross stovepipe use cases where having data coming from multiple different IoT infrastructures and IoT paradigms, and being able to bring all of that data together into a single view. Really, again, as we talk about machine learning, that's really the next evolution of having full visibility across everything that's going on, across a city, across a plant, across a warehouse and distribution floor, and be able to bring that data together. And so that obviously creates new challenges, both from a compute standpoint and a network integration and services standpoint, where we now need compute even closer to those aspects, because building all those things together, we really need the ability to have that happen even more in real time to be able to adjust as we need it. So the concept of using compute on a premise, compute in we'll call it a metro edge or a near edge capability, as well as the cloud, and being able to have all of those out there, and again, really being able to bring all of those pieces together and be able to move compute around between those different locations really has become critical.
Right. So what I'm hearing you say there too is, with all the possibility and all the complexity, the challenge of integration never goes away. Right. Getting things to talk to each other in very specific and requirements compliant ways is really where the challenge still fundamentally lies. So as we start take that historical message and maybe kind of pivot it forward to how companies are actually strategically approaching this fourth industrial revolution, this world at the edge. And what's HTC's approach towards the edge? What's your sort of corporate strategy around distributed computing and edge devices?
Well, edge computing has really been the proof point of how we're going to hyperscale XR technology in general. We went from a tethered and a PC and all this heavy equipment, all these localized needs, and literally putting it all in the cloud and putting it in the edge of the network. Being able to deliver content, high polygon, 90 frames per second plus, with very, very low latency content to headsets or wearables or glasses. Like this is the technology that enables the adoption of XR technology for whether it's B2B and enterprise and businesses or consumers at scale. It brings together, safe delivery, secure delivery, quality and performance that 5 years ago you needed, dedicated equipment in a room for, and tracking. Now you can actually do all of this in the field with a distributed workforce, localized, content for that workforce. And you can have those kinds of, collaborations, inside of your corporate environment, whether it's training or collaboration. You can actually now deploy this at scale and give your employees and consumers these great experiences over a cloud. And so when I look at the origination of XR technology, from years and years and years ago, and where we actually tried to deploy it at scale 5+ years ago, this is really the railroad system that's actually going to deliver content to these types of devices that are going to be used openly by consumers and companies.
Yeah, the HTC and your whole Vive portfolio, clearly a company geared up for geared for the edge and geared for that more intelligent world in a distributed model. Rick, how does Microsoft certainly a force in the industry broadly from IT perspective, but how does Microsoft think about the edge and what's the strategy there?
So Microsoft is a platform company, right? Platforms are a core business. We're not an ad company. We're not a retailer. We're a platform company. That's where we make money. And the edge is a platform. So we view it very much as our core business. It's really important to note that since the inception of Azure, which is our public cloud, this was back in 2008, we've always promoted the need for hybrid cloud. We always expected that some workloads, for whatever reason, would need to run on-prem. Things could be data sovereignty. It could be regulatory reasons, performance, security. Anyway, lots of things will need to run outside of a hyperscale data center, no question. And so what we were calling hybrid cloud back in 2008, what is it? Maybe a more fashionable term for it is edge, but it's essentially the same thing, right? And the edge really means different things to many people. For example, how far does the edge extend? Our vision really is to span the entire computing canvas from the device or the thing itself, as Chip was mentioning, in an IoT context, all the way to the public cloud. And there's a lot of edges in between, right? Even the end device is an edge of sorts. Like I explained earlier, the value proposition really is to ensure that the same DevOps model, the same cloud native model are able to be leveraged across that entire spectrum. So, for example, we have secure, hardened, cloud native, embedded operating systems, things like Azure Sphere, and so you have now an edge-enabled OS that can be placed in an MCU. We have intelligent edge AI devices like Azure Percept, which really include high cameras and also an onboard neural processing unit, so you can run machine learning models on that device itself and do vision analytics right on that device. We have a whole slew of Azure Edge capabilities, things like Azure Stack Edge, HCI, or hyperconverged infrastructure, which we partnered with Lumen to deliver, and of course, all the way to the hyperscale cloud. There's a lot of edges in there, and we don't deliver on this cloud and edge vision alone. We do work closely with our telco partners, not only to deliver the connectivity. Yes, that's important, but we really want to work with our partners to deliver end-to-end edge services and capabilities. With offerings like Azure on Lumen Edge computing nodes, for example, which enables us to unlock more low latency, high bandwidth types of use cases for Azure customers. Imagine now if your Azure workloads really have less than a 5 millisecond latency, they're securely hosted in the edge location that's closest to you. That's the kind of capability that we'll deliver together with partners like Lumen.
Yep. So Microsoft clearly has an evolved and really focused strategy at the edge. Chip, from a Lumen perspective, in your position, delivering services that span from the cloud to the edge, how do you really think about Lumen's strategy and what the edge means to the company?
Yeah, absolutely. So, as I said before, needing to have all of the tools in the tool chest to be able to solve a customer's problem, right? So, obviously, we've talked about the cloud and the use cases around that, and we've talked about premise and the use cases around that. One of the unique things that Lumen provides is what we call our Metro Edge compute capabilities. So, these are cases now where we've been able to leverage our central offices and being able to leverage locations where we used to have these big Nortel 5E switches that took up large areas of real estate inside of those spaces. Now, as we've gone to more of a soft switch type capability, now we have great advent of the use of a great space with power and cooling and obviously being right on our backbone, great network connectivity options. And so by being able to now decentralize those across up to 100 different locations across North America and across the world, we're able to now bring compute, within 5 milliseconds of most industrial locations. And so that gives us kind of another tool in the tool chest to be able to, not be dependent on, hey, I don't have space in my manufacturing plant or my mixed use development to be able to put up, a whole compute infrastructure, and the cloud's too far away. I get, poor application performance, or my production line doesn't work well, when it's, all the way out across the country in Ashburn or San Francisco. So in those cases, now we're able to put compute very close to the customer's use case without being dependent upon their real estate and not having a huge impact on application performance. So it really, again, doesn't compete with the cloud, but it really kind of completes the overall solution and those capabilities.
That's great. Yeah. So from those company strategies, and right, in the ways in which HTC and Microsoft and Lumen are really approaching those markets, that has to open up a number of really interesting use cases. I'd love to have everybody spend a couple of minutes talking about what are Dan's, to start with HTC, what are the use cases you're really excited about? What are some of the coolest things you can do when you incorporate the edge that you can't do in other ways?
Sure. And I really appreciate Chip's last comments about taking, almost that last mile and bringing the network and the capability right to the customer premise and solving so many of those problems for them. What we're seeing is training and simulation across the board, whether it's in healthcare, education, safety, automotive, aerospace. We're seeing training and simulation as being one of the most overwhelming positive impacts and deployment use cases. Companies are upskilling, training employees into newer, more advanced roles where they may be not able to even find that talent. We're seeing hospital networks connect multiple hospital locations in collaboration on patients for better outcomes. We're seeing safety training for officers, so that there's better outcomes, safer outcomes. Now you have training at scale, distributed, and everything is coming back, to a centralized location. You can actually measure the performance of that training. You can measure the value of that training. You can see the impact of it. So now you have scale, you have more cost-effective, more effective training. The human factor just becomes more efficient and more effective. Everyone wins in this revolution, quite honestly. And so we're pretty excited about where it's going and the different use cases and how it's going to deploy.
Better skills and better healthcare, and those are all real positive influences on humanity. Rick, what are some of the exciting things that you're seeing from your approach at Microsoft that you think are just exciting? You can't do them any other way.
Yeah. No, but David, I was fully expecting the killer app question, because I get it every week from telco customers that are investing in building out their edge and their 5G infrastructure, right? What's clear is that the business as usual is not going to generate sufficient revenue to really fund all these build outs, right? So we need to consider, what else can we do? What's clear really though is that most scenarios seem to be coalescing around video for us, right? Video processing, video analytics, video artificial intelligence. But we have to remember that in order for the edge to be exploited by developers, and that's what we're looking for, we want developers to build at the edge. But the edge really needs to bring value to those workloads. And that means that we really have to find the applications or categories of applications, like we did with video, that can really take advantage of those unique features that are enabled by the edge: higher throughput, lower latency, higher security. Because again, another point is that hosting services at the edge will be more expensive than hosting those same workloads in the public cloud. It's just a function of scale, right? So the resources are much more limited at the edge, and thus they'll be more expensive. And so we've learned from our experience that you can't charge more for the same service. And so for developers to run on the edge, they need to see value. And so we think that video is that workload, which does indeed take advantage of these unique benefits, higher throughput so that large video streams, large files can be transferred faster, processing at the edge, right? You want to be able to process that video close to where it originates. And you're not sending huge files up to the public cloud, which impacts performance and can be very costly. So, some video, and I think, Dan, you had some great examples, around, for example, manufacturing and workplace safety as an example. Let's ensure that hard hats are being used in dangerous locations. Make sure that dangerous tools are managed appropriately and returned to safe storage after they're being used. This is an edge AI vision scenario, right? And you want to process that video at the edge. Around healthcare, as another great example, we've seen some customers do patient monitoring. Placing these edge devices, say, in a hospital room, so they can ensure that patients are safe, they stay in their bed. Even these sensors, these cameras can monitor vital signs, right? They can use not only just traditional cameras, but infrared cameras, LiDAR, to ensure that, for example, they can check temperatures. They can sense temperatures on a patient. All sorts of interesting use cases. A vast majority of these edge use cases involve video in some meaningful way. And so we've invested a lot. We've invested a lot really in building video analytics and AI capabilities that run at the edge, where these are the kinds of services that we can jointly deliver with Lumen. We've already done this with hundreds of customers, and they're really inventing new use cases to exploit at the edge, exploit vision at the edge. But maybe the most exciting scenario that's in everybody's lips for the edge is the metaverse, right? And what is the metaverse but another use case for video, right? Maybe how is it different from video today? It's more like, say, a live video stream, because the environments, the metaverse environments are very dynamic, and it's also two-way types of videos, right? So we do need a new set of edge APIs, of network APIs that enable a bidirectional dialogue between a client application and the network, so that, for example, the client metaverse application can request the right level of resourcing from the network. It can fail gracefully if the network changes in any way, and it can make more efficient use of the bandwidth that's provided. Like low latency services as well. So that's the future, and that's what we're aiming for.
So video and as one of the main killer apps, and all the different derivative ways of feeding off of processing video in the built environment. Certainly an exciting set of use cases there. Chip, from your perspective, what are some of the exciting use cases and solutions you're seeing when piecing it all together?
Sure, absolutely. And to build upon kind of the video theme that Rick introduced, and I'll use a kind of a retail example in this space is. And being able to leverage all the different compute assets that are out there. So when I look at kind of the world, I look at what I call video processing, reporting, and analytics, right? And so when I think of say in retail wanting to do shopper behavior using video, we're at the premise edge. We're taking those video streams, breaking those down, doing the real time processing there, where we're creating in essence metadata out of those video streams, and I can take that metadata, say in the shopper behavior case, how many people were in the store at any given time. Well, I can take a snapshot of that every 5 seconds, 10 seconds, 20 seconds, and maybe a picture of that, and then the counts and the time stamps of that. Roll that up into a metro edge where maybe I'm taking that same type of data from multiple cameras in that store or from a regional geography standpoint, and being able to analyze that and be able to get statistics and trending and what's happening across that, and then being able to take that reporting data and roll it up again one more layer and bring in third party data, maybe other historical trending from other similar types of business, and bring that into the cloud and really crunch some large scale data to be able to get even more information out of it. So as we look at the ability to leverage compute in every one of these locations, it's that continual synthesis and rolling up and extrapolation and integration of other data sources that really create the power when you have all of those tool sets at your disposal.
Yeah, lets you be so much more efficient. Right? And sometimes the art of the possible is an economic argument as well. And if you can be more efficient, you can do more things. So with that, I think that's been a great historical perspective. And I think history has taught all these companies that there's huge opportunities at the edge. And we're seeing a lot of exciting use cases really starting to emerge from what real technology companies are doing in this dawn of the fourth industrial revolution. So I want to thank all of our guests. Thank you for everyone here at Transform 2022 for listening and tuning in. And hope everybody enjoys the rest of the event.